Alright, so we were looking at the volumes of the solids of revolution by using the disk method, which is, it's great. And if you were to cut up that solid that you created, every cross section would be a circle. That's what it is. That's what the disk method is. So now we're going to look at solids that are not revolved, but instead, what's happening here um, is that every time we do a cross section, it's going to be a certain shape, and it's going to be a shape that we know the formula of. So we're going to see if we can't figure this out, and it's kind of difficult to visualize these in 3 dimensions. It is a little bit of a challenge, but it's not too bad. Um, like I said, it's just a matter of trying to figure it out. Anyhow, um, that's about it. Let's try these out. All right, so we're going to start off with something that's not so bad. We're going to look at the region bounded by these equations. So this is y equals 1 minus 1/2 x, and this is y equals 1/2 x minus 1. And you see we're creating a lovely little triangle there. And I'm going to try and visualize this in 3 dimensions. So what we're going to do, I'm going to kind of slant this down like it's on a piece of paper, okay? So bear with me a little bit. Here's our here's our base. Okay? Now what we're going to do, our known cross section, we're going to make each cross section of this triangle another triangle, and the triangle is going to be of specific ratios. So it's going to be an equal, not only, excuse me, it's going to be a triangle, and you kind of have to know the area of your cross section. And this triangle is going to fit a certain pattern. The base, if this is the height, the base, the height is going to be 1/2 the base. Okay, so the height is half of the base, and that's actually going to create a pretty nice triangle to deal with, because I don't want to go crazy and give you like a crazy formula. So the area of this triangle, of this ratio, the area of this triangle is always going to be, it's 1/2 base times height. And the height is 1/2 base, so 1/2 base times height. And if we multiply that out, that's going to be 1/4 base squared. Okay, don't worry too much about that. So now what we're going to see is each cross section of this is going to be this exact triangle in this ratio. So, how are we going to figure this out? Let's see. The height, so this is the, so there's our triangle, right? Here's another one. Here's another one. Hopefully you're seeing a solid kind of forming. Okay, are you kind of seeing the solid forming? Yeah, so if you were to cut up, if you were to cut up the solid, each cross section would be a triangle of this ratio. Okay, so, I would really, really recommend you look at the textbook and look at some of the shapes that they have there, because obviously their images are way better than the one that I'm drawing, because, I can only do so well. So, yeah. Um, Hold on one second. Oh my. Don't worry, I'm not sick. All right, anyhow. So let's actually figure this out. So the difference was when we did the this method, it was um, it was each the little disc. It was the area of the circle, and then times the height of the disc, which was the dx. So we're going to kind of do the same thing, except we have the area of the cross section, so we figure that out on here, and by looking at this, and you'll be given like the area is a semicircle, and then you'll have to get the formula for a semicircle or something like that. Um, but either way, you'll have to figure that part out. So anyhow, when we do this, let's set it up. So volume of this shape is going to be we're going from 0 to 2. All right. We need, the area is 1/4 base squared. That's the area of the cross section. So we're quite literally putting that in, 1/4. The base, however, is what we're going to get from, this is the base, from here to here. So we are going to get the base by subtracting these two equations. And it's going to be different for each one, so you're going to have to figure this out. So the base here is going to be 1 minus 1/2 x minus 1/2 x minus 1. One-fourth base squared. And then, of course, to do this like across the thing, we always got to stick that dx in there. That's the height of the cross section. Yeah, that's just the whole integral part. Okay, so that's how we figure this out. Now let's do the math and actually figure it out. So first thing I'm going to do is distribute the negative sign and subtract all that stuff. Oh, I could have pulled that out front. I'll do it later. Okay, 1 minus negative 1, that's going to be 2. And then negative 1/2 minus negative 1/2, or excuse me, negative 1/2 x minus negative 1/2 x, that's going to just be negative 1x. 2 minus x squared dx. All right, let's pull the 1/4 out from 0 to 2. Let's FOIL that out. So 4 minus 4x plus x squared dx. We can now integrate that. 1/4 from 0 to 2. I'm going to integrate this. And, oops, I always forget. Now from the 4 is going to be 4x. This is going to raise up to 2 multiplied by 1/2, so 2x squared. This is going to raise up to 3 multiplied by 1/3 plus 1/3 x cubed. And that's from 0 to 2. All right, that's now enough for us to do everything. 1/4, let's plug in the 2 first. 4 times 2 is 8. Minus 2 times 2 squared. 2 squared is 4 times 2 is 8. 8 minus 8 plus 1/3 times 2 cubed. 2 cubed is 8 times 1/3 is 8/3. Minus, let's plug in 0. What's going to happen? 4 times 0 is 0. Negative 2 times 0 squared is 0. 1/3 times 0 cubed is 0. This whole thing is 0. Anyhow, 8 minus 8 cancels, so we're left with 8/3 in here. So 1/4 times 8/3, this whole volume is going to work out to be 2/3. All right. This one's a little bit different because there's not an exact formula. Let me give you 2 of them to try.